All right, time to go. Don't give a fuck. Okay. Damn, Clear Obscure is such a great game. The combat is just fucking perfect. Enough enemies to where you learn what's going on. I don't know. It's difficult in some cases. Fantastic. The sounds and everything, animations are so satisfying. Okay. Got the fruit water. Where we at? Oh, good. I broke the page. Amazing. What is it? Just like we. Yeah. Empty curly braces after each member variable, like struct fuck you is an int fuck me. And then I can make a fuck you called yo, and I can initialize it with whatever, nothing. So fuck me is 0 or 50. Fuck me is 50. And then if I want, I can prove that by getting some IO stream action because we need standard character output. And then we can do yo dot fuck me to get, well, I don't know if it's, yeah, that's it. Yo dot fuck me will get the value of the data member integer fuck me. Bop. Cool. Okie dokie. Ensure that each is value initialized. Yeah, exactly. Instead of left uninitialized, and then we call it thinking, oh, it was empty when we made it. Oh. You at least want to give it a fucking default argument if you're going to do that. Like a minimum mass for creatures in the game, maybe. Where the fuck are all the blueberries? There you go. I recently started enjoying blueberries. Okay. My shoulder is still whack. Empty set ensures each one is value initialized. Makes sense. Just like a regular one. And we end the type definition just like an enum with a semicolon at the end of the ending brace. Employee is just a type definition. Yes, no objects are created because we ain't making one in main, yo. We're just defining that this is a thing that can be created. We don't have to use it. Same with the template function. We create a template function. There's no specialization at that point, buddy. Once we add some function calls in compiler, boom. Well, all the blueberries are at the bottom of the bag. I hate that. It's less annoying than the antioxidant fruit blend, though. Because that shit, the amount of fucking raspberry seeds, oh my god. They just collect at the bottom and they look at the exact same. It's like picture a raspberry with all these little bits on it. One of them is fucking hard and you can't bite through it. So you confuse it with all the other ones that fall through that you can bite through. Very annoying. It's like pretend an entire apple is sometimes just an apple seed, but it looks the same as an apple. You'd bite into that bitch and then your teeth would hurt. Very annoying. No objects are created. Yes, it's a definition, buddy. Or rather, it's a type definition. It's not actually, it's not a variable definition. Defining structs. We need to define a variable of type employee. Makes sense. We can make employee Joe, and in this case, it's literally, there's nothing in it. I don't like seeing that, because it means it has no data members at all. It's got nothing, so we can't even initialize it with anything. Hold, what? What are you saying? An employee object Oh, you're saying we've already created one. Okay, we already created an employee with these three things. And this is the statement to actually create one. Okay. Defining the variable versus defining the type. Okay. I was like, I thought, because the weird part is, well, I guess it doesn't say struct, so, and this is the name. I was stupid. Never mind. I was thinking this is the type definition, not the actual variable definition that was retarded. Okay. Excuse me. Excuse me again. We got the employee named Joe. Cool. Yep. We have the object. Yep. Yeah, makes sense. Multiple variables of the same struct type. Well, yeah, makes sense. I mean, we could create a Mersenne twister called this, or a standard string called that, and another one called that. Boom, boom, boom. Joe and Frank. Accessing members, we do employee. So whatever the name of the object is, dot ID, dot age, dot wage. Ah, the member selection operator. Okay. In the above example, the name Joe refers to the entire struct object. Okay. What was I doing with operator plus yesterday? So we did operator insert the insertion and extraction operators in order to extract and whatnot for strings. But oh, it was to convert it. And that was to print or extract it. But to actually just convert it straight up, we could just do it plus instead of having to do it in as an argument in a function. Could we do the dot operator like that? Would it be allowable? So if we said in Pokemon Eevee Whalelord, or is it Whalelord? I don't even know what he's called. I mean, it's got to be Whalelord. But that doesn't look like it's spelled right. And we'll say Dragonite, some shitty ones. Oh, Tyranitar, yo, that's the best one. And then we have a function to convert these guys to strings. And then we'll say it returns a standard string view. And it's called operator dot. Oh, it might not be happy here. We're overloading it to get. Take a Pokemon, or it just takes a Pokemon. Ah, it doesn't like it. Yeah, it doesn't like that. We could do operator plus, but we can't do operator dot. Damn. It's the member selection operator. It's not overloadable. Yep, Joe's the entire object, and it holds three things. We can get the members from it by doing Joe dot that. To access the specific member variable, we use the member selection operator, operator dot. And it's because it's binary. Gotcha. Well, and only binary, whereas yeah. Yeah, it doesn't work. In between the struct variable name and the member name. Yeah, it dot whatever the name of the thing is. So to get Joe's age, Joe.age, yep. It works just like normal variables, so we can do operations, arithmetic, assignment, comparison. Okay. Makes sense. Yep. We can create Joe with nothing. We can set the age to be 32 now. We can output Joe.age. We can do all this stuff. Now we only create one new name per struct variable instead of all these new ones. Two employee objects, Joe and Frank, for example. So we create Joe, and we can later on set it to be Joe's ID and Joe's age and Joe's wage, and then we can have Frank, and he's doing the same shit here. Younger, making a little bit less. His ID is the next employee, probably. We can say that the total age is the sum of their ages. They've lived that many years. We could say if Joe's wage is greater than Frank's, he makes more. Otherwise, he makes less. And then finally, otherwise, they make the same. Oh, Frank got a promotion. We can update Frank's wage to now 50,000, and then we can increment Joe's birthday. Yeah, that's cool. Yeah, it's so much better. Aggregate initialization, is that going to be the difference between here? Because here we're assuming default or we're doing value initialization with braces, but we would want to do braces and then do 15 comma space 28 comma space 45,000.0. Yep. It would be cool if I could select, I could match on the name and then have something dynamically choose which one, but maybe that's not actually needed. I just passed the right object and then we might be fine. What if we have a bunch of guys and I want to get the one with the highest something, and I want to loop through the guys? I guess that's when you have an array of objects, and then we can test that way. The previous lesson, we can define structs, instantiate them, and access the members. We can initialize them now. They're not initialized by default, just like regular variables. Yeps. Makes sense. I did it again. No initializer, undefined behavior. We're gonna get an issue here. So we haven't created, well, we haven't initialized Joe's ID. So, try to print it, no go. Yep. An aggregate type is a type that can contain multiple data members. Yep, which makes a struct an aggregate. Because an array is an array of integers or an array of employees or an array of whatever. Okay. Definition of aggregate is narrower. Hold on. In general, is that. And some aggregates allow for having different types, but some must be of the same type. But in C++, it's narrower and more complicated. Oh, good. Aggregate. It will mean the C++ definition. Okay. An aggregate in C++, there's a C-style array or class that has no user-declared constructors, no private or protected non-static data members, why does that matter? Does it mean that if it's a static data member, how does that even work? Because it's an object that's created. I get static for a function, but static as a data member in an object, it seems like when the object is destroyed, the data members are destroyed. And if it's not, I'm not sure why you would want static. No private or protected ones? So everything has to be public if it's not static. Okay. Oh yeah, and they said static is overloaded, so I think static is a different use case there. It might be like another way of making things have internal linkage. No virtual functions, okay. Standard array is also an aggregate, okay. Structs with only data members are aggregates. But wouldn't a struct with a function still be an aggregate? It would just then depend, maybe, on what's in the function. Aggregate initialization. Okay. So we provide an initializer with each one of the guys. So we got int x5. But if we have struct, we need to initialize them in order. And it would probably be just like a regular function where the default argument data members or data members that are, well, maybe not. Yeah, if age is normally something, I can't skip it. Seems like it's like a function like that. So if I want to specify ID and wage, I also have to specify age, unless I put age at the end and give it a default value. Employee Joe. How do we do each one of them? Okay. Brace initialization with commas and spaces, yo. Aggregates use a different type of initialization. Okay. It's not list well, it seems like it'd be called list initialization, but I guess list initialization is initializing one list with multiple values of the same type. So in this case, maybe it's different because they don't necessarily have to be the same type. An initializer list is an initializer. Okay. Two different forms, huh? Oh, so there's copy. I don't know why we would want copy list. Prefer the non-copy. Okay. Need to pop my knee. There it is. Okay, let me make sure my voice is loud enough for that fucking guy. All right, yeah, we're good. Each one does a member-wise initialization. So what? It looks at the first and matches up with the first, and the second and the second. So if we pretend this is a list with indices 0, 1, 2, and we treat this like an enum, where these guys are accessible via 0, 1, and 2, 0, 0, 1, 1, 2, 2. Or it's just like a function, and we don't have to worry about the numbers. Each one is initialized in the order of declaration. So it's ID and then age and then wage. We get ID and then age and then wage. Don't do the copy one. I don't know why we would do that. It seems like maybe there's a helpful thing. I mean, it could be to allow narrowing conversions, because if we do list initialization, it disallows narrowing conversions. But if we instead just have a list of things and we are copying the values, then we shouldn't care about narrowings. Okay. We can also initialize. Let's see if that's the difference. Struct candy. Warheads. Snickers. Wait, what? Hold. Oh, okay. We'll just do an int, sure. Should I? What was I gonna test? Oh, no, I guess we don't want that. We want struct weights. Weight 1. I will say int weight 1, or what do we want here? Double weight 1. 3.0, sure. Well, let's just say it's value initialized. Double weight 2. Excuse me, same thing. Int main. But then I get he was doing it like that. So we could, if we're initializing it like that, we could actually just make these be. What if we said these are both ints, or an int and a double? And we say weights, my weight, and we initialize it with 4 and 10.0. Okay, we're cool. But if I have weights, my weight 2 and we do 4.0, 10.0, no go because we get narrowing conversion. But if we copy, never mind, still narrowing conversion, okay. So it still looks at the weight and is showing what we're initializing things with. Okay, never mind. I don't know when we would want to do the copy. If the brace is aware of the types that are needed and shows that there are narrowing conversions straight in the brace. So the copy does not remove the narrowing or allow the narrowing. I'm guessing these rules are going to be the same as as default arguments for functions. We can also initialize some aggregates using a parenthesized list. Some aggregates. Oh, good. Avoid the last one as much as possible. Nice. They utilize brace elision. I have no idea what elision is, but that's a cool word. Please don't fucking pop in my ear. Robert. Okay. Missing initializers. If it's initialized but the number is fewer, each one is initialized as follows. Hold on. If it has a default one, that's used. Otherwise... Oh. The point is 228, and then we're going to say wage is already initialized, but then whatever would be value. Oh, so there's some safety built in, seems like, where we don't have to actually worry about them being undefined. Isn't that right? Or at least off the rip, if they're uninitialized and then we use it, no go. But if we initialize some of them, or if we initialize anything via list initialization, then all of them become valid and at least value initialized. Okay. If it has a default member initializer, that's used. Otherwise, it is copy initialized from an empty initializer list, which should be 0. So we have ID, value initialized, age, value initialized, wage 76,000, whatever, uninitialized. We overwrite ID and age to be 2 and 28. We leave wage alone. It stays as is because it already has a default initializer. But then whatever is uninitialized, it will be copy initialized from an empty initializer list. Therefore, it should get 0. I.e., if they're all uninitialized and we use one little brace, we're not specifying any of them. By default, they all should get value initialized to 0. GeoID or an empty string. GeoID is initialized to 2, and then age is 28. Shows wage wasn't given one, but it already has one. Yep, so it's good. And then Geo whatever is value initialized to 0. Cool. All right, full safety. I'm down with it. This means generally use an empty initialization list to value initialize all members of the struct. For structs, because we can. Okay, so I could have a struct. Do I want that in the struct though? I guess not. No. Okay. What if we do? Actually, we don't even need that. Maybe we don't need anything. Oh, I did need string though. candy, warheads, standard string, warheads, standard string, Twix. Oh wait, these are separate variables. They need to be, they're not enumerators. And then we can say returning, we also need include IOStream because we need standard character output. And we can overload to get an OStream reference to return itself for chained output. And it'll be called operator insertion. And it takes a standard OStream reference, and it takes a reference to candy reference, this candy, and this should be called output device. Device. And we're gonna say standard character output candy hold. This candy dot warheads this candy dot Twix. Sure, something like that. And this, I fucked up again. This should be output device because we don't know what device we're actually using. And then return the output device. This is easy enough. And then we're gonna just say, okay, we have candy, my candy. And it's left as is. And actually in this case it's being value initialized. So if it's default like this, they already have the, well actually no. If we value initialize it like this, it will leave its shit alone. Because we're not specifying which ones to overwrite, I think. And then we could output my candy. Nice, okay. So doing this keeps one with its default arguments intact, or its default initializers intact. That's good to know. I'm gonna have to cook after this. Okay. Same shit. ID and age are specified, but wage is not, so it's 0. Then we can output 228 0. Unlike an enum, a struct can hold multiple values. Okay. Yeah, because in enum we're just printing the value that it has. Whereas with a struct, we can print whatever we want. Any of the things it has. 3 values output by our overloaded. So there's no indication. But yeah, we would want it to be, hey, here's the ID, here's the age, here's this. I mean, that's just a dumb design. I don't know why you would write it without that. And then, cool, we say that, we say 228, left is 0, we output it, and wage is 0. Yep. A const struct, does that mean that the variables of a struct can be const or const expression, and they must be initialized? Okay. Oh. Interesting. It's just that they can't be changed. They're initialized when we create that instance of the struct, that object. And we're not stuck with the only values that they have, because this isn't actually an instance of a rectangle. Okay. Oh, hold. Never mind. It's not a const struct definition, it's a struct. And we can make one that's const, it just has to be initialized. Okay, I gotcha. Gotcha. So we can have like struct I don't know, what would we have? World, and it has an int enemies in world, or max enemies in world. Okay, nothing. But then we could say this world dot max enemies is now 3. No go because it's const. Wait, hold on. We haven't made it const yet. Nice. So once we've actually created the object, if the guy is const, no go. Or if we leave it like that, well, it has a default initializer. But if it didn't, automatic const unreliable results. Unreferenced loop variable. It's an uninitialized const basically. It's compiler generated default constructor. The constructor isn't giving it the same result each time, or it's at least not making it safe to use. It's not value initializing it every time. When initializing a struct from a list of values, yeah, we already said this. Create a foo, call it f. 1 goes to A, 3 goes to C. Specifically, it's foo.A and foo.C. Well, it's not. Oh, well, in this case, it's f.c. That's right. This is the object, not the struct. We added a new one. Oh, we added B. Now B is the one that gets 3 instead of C. And we had it. C was supposed to get 3, but now C is getting 0 because B is the one. Designated initializers. So if there's a way to say this one is for this, this one is for this, this one is for the 0 index, this one is for the 1. That way, if we add another one in the middle, specified. Oh. Yeah, it seems like it's just a semantic issue. Designated initializer. Explicitly define which initialization values map to which members. List or copy list, or list or copy. What are you talking about? Oh. So we create a foo called f1, and we initialize .a with 1 and .c with 3. Or .a with 1, .c with that. .b, .2, .a. Oh, they must be in the order. They can't be out of order. Gotcha. It doesn't have to be right before, but it has to be before. A has to exist first, it seems like. Okay. Interesting. Go to the bathroom real quick. Okay. Alright, so I could make... Let me get music. No. Let's do... Sure. So they have to be in order. So we can skip some things, but I can't do like A, C, B. It has to be A, B, C. But it could be A, C, could be A, B, could be B, C. What struct do I want? Oh, we could do enemy property. So we'll do an enum class. Enemy property. Invisible, I don't know, aggressive, perceptive, something like that. And then we could have just a struct called enemy, and it has an enemy property 1, enemy property 2, and then int health, and then int speed, int damage, something like that, and maybe they're subject to change so they're not const. And then I could create an enemy and call it enemy Ustrel, and it has we could say dot property 1 is invisible. Oh, and to reference this, it's a scope denum, so I need to say enemy property invisible. The second one is it's aggressive. Oops, hold. Dot property 2, enemy property aggressive. And then it has, we'll say dot speed is 100, and then dot damage is 500. And then I could have, it would print, it wouldn't be able to print those actually. So I would need a way, I would need to overload it, and the overload would call a function with these enums as a, let's do it real quick. Okay, and it'll be called these could be in their own namespace, but it's fine for now. Let's just say cool. And then we could have a standard string view returning function called get enemy property as string. Yeah. And it takes an enemy info, enemy property, this property. I would just call it property. Let me say case. We could say using enemy info, enemy property, case, visible. Wait, hold on. Oh, here we go. Using enum. There it is. Yeah, there it is. All right. Case invisible. Return invisible. Case. Oh, well, this isn't even switching. Case aggressive. Return aggressive. Case perceptive. return perceptive, default, return invalid property. And this could be in here too. Just in case stuff moves around, I'll use the explicit scope resolution. Time goes so much faster when I'm actually writing a bunch of code. Not that this is a bunch. Let's see. Excuse me. We're gonna return a. We need a IO stream. We need character output. Reference to no stream operator insertion. Standard OStream reference. Enemy info. Hold. Wait, what? What is happening here? I don't know why it wasn't auto completing there. Actually, this should be. We don't need that. Like, see that? I don't know why it's doing that. Now it's fine. And when we output an enemy, we output we have to pass it in. And again, I did it again. Output device. Return output device. And now we can output it's the only thing, it shouldn't be ending an extra line. It's invisible. Health, speed, damage, cool. And then I could do the same thing. I could put the name in there as well if I wanted. But cool. And in this should be a const expression function. And that's it. Cool. Those are designated initializers. Let's see. And what did we get there? So we're outputting all the stuff. And all I set was property 1, property 2, this. The health in this case was 0, right? Yeah, health is 0. But I could set it to be different stuff. And I could also put in here using enemy info and that kind of stuff too. Same order, not out of order, yo. Oh, because it's thinking a scalar, meaning meaning a vector without a direction. This looks like the syntax for that. Where we say, hey, here's the x, here's the y, here's the a, here's the b, here's the c. Oh, but the problem would be designated initializers of single values, meaning that there's only one data member in there, I think. Because instead of it seeing, oh, hey, this is a vector because it has an x, a y, and a z, it's thinking, oh, it's just one thing, it's a scalar. Yeah, it's pretty good. Yeah, they do clutter it. It's true. I mean, yeah, it makes sense. You would just add it to the end if we have something. It's like, oh, hey, we have, let's say earlier we have enemies that have health and damage and a name, but then later on they get specific properties. And then we end up storing a move set there. We store an array of different moves that are possible. That way we can loop through them and give them a move set and behavior. We get references to it because those are expensive. They're like animations or something. Then we'd put them at the end. We wouldn't put them in the middle of shit and then go and do some direct or some funky list or some funky initialization elsewhere. I'm adding a new one. Add it to the bottom. Agreed. It's to fucking assign value to it. Oh my god. I was wondering why it would be initialized like that. It's the same reason you use copy assignment for assignment. You can't initialize. You can't use braces to reinitialize it. So like if we had struct firearm. And we have Glock 17, Glock, Let's just do int Glock 17. And then we have int Glock 43x. And then int Scar 17. Okay. Alright. I was itching. And then we create a firearm. Well, collection. And then we'll create a firearm collection. And we initialize it like this. Oh, and we call it my collection, or my F collection. And then I take my F collection and I initialize it with 3 or 4, 3, and 2. Can't do it. It's already initialized. Let's see, hold on. But I could assign it this. That's the difference. It was already initialized with 0, 0, 0. I can assign each one individually, or I can just do the copy list assignment. Oh, this is really good. Honestly, this is pretty good. Not lyrical enough to where I get distracted. I've been getting better at that anyways. Thank God it's member-wise. It's random. I think after I finish chapter 13, I'm going to make a little project. And it'll be the card game. I might be able to do everything. I'm not sure. Ooh, but if we do aggregate initialization and the struct contains a function, do we get an error there? I'll just make a quick one that has two. It has one variable and one function. Too many. Oh, okay, cool. Seems like it's alright. And then what if we said int B, int C? Okay. So we could do 0, 0, 0. If we do another one, too many, we could do dot I is 4 or 3. And then we do dot C to skip B to be this. And then we need another to close the list. Okay. Didn't want to change it. Hold on. We didn't want to change Joe.id. Oh, because if I leave it, if I'm assigning it and I pass it in. Oh, well, it seems like, yeah, we would just. We just assign only the specific one. So we say, hey, Joe is dot age 33 dot wage 60,000. Oh, and designated initializers need to be equals. Why the fuck would I do this? Why would I do that? Why wouldn't I just leave it? Are you sure? It's still ugly. We need to provide it so that member-wise assignment could assign Joe ID to Joe ID so that it doesn't change. Because if Joe is this, and I'm assigning, I'm updating a bunch of things in Joe, I have to pass the current values in. Is that right? Really? Okay, we have dealer Steve. Then we update him to be Steve is now dot product 2 is 3 and dot product 3 is 4. Okay, and then we say output see product 1. Well, I mean, we could just, yeah, why not? Stream reference, operator insertion, stream reference, dealer, dealer, output device, product 1, dealer dot product 1, product 2, dealer dot product 2, product 3, dealer dot product 3. Here's before the update and after the update. Oh, oops. Oh shit. If we pass in the list, it's going to overwrite whatever it is. Or if we say, what if we put it at 5 and we override it to be 1? Oh, and then we omit it, it's gonna go back to whatever the default value is. Okay, this is funky. So if we're never gonna touch 1, well, I mean, we may as well make it const at that point. So if a guy throws out 3 cards, now we can blank out 3 of his those 3 cards. And we could leave the other 2 to be whatever. Like if you use card 1, card 3, and card 5, this is actually useful. Card 1, card 3, and card 5, then we could either explicitly blank out 1, 3, and 5, and then explicitly say card 2 is card 2, card 3 is card 3. Excuse me. The value that would have been, if we hadn't specified a specific one, then it would have been that. Okay. So we could do struct hand. Sure, int card 1. Card 2. Don't like this. I wish it automatically got rid of that, but we have 3, a 4, a 1, a 1, and a 2. And then I update my hand to be dot card 1 is now nothing. What if we do this? Oh, I could do it like that. I don't have to say equals that. So like I could initialize it with some special values. dot whatever dot whatever dot whatever. Or I could just do like this. Card 1 is now nothing. Dot card 2 is still. Hold on, it's still. Yeah, I guess it is. My hand dot card 2. Dot card 3 is nothing. Yeah, and then dot card 4 is my hand dot card 4. And then dot card 5 is my hand dot card 5. And really in this case, we're just gonna say this is nothing. That way, keep cards 4 and 2, but the others are gone. Okay. So we use these, and then we say remaining cards. My hand. Then we can go over here and do standard OStream reference, operator insertion, standard OStream reference, output device, and boom. So we say, oh, actually we don't know what it is, so we'll say initial hand, updated hand, so we say the first, we have 1, 4, 1, 1, and 2, or hold on, what the fuck, 3, 4, 1, 1, and 2, but then we say we use cards 1, 3, and 5, so now card 1 is nothing, and then 4, and then nothing, and then 1, and then nothing again, something like that. The one hard part is to check how many cards. I guess we could make a function that only outputs. We could have an if. Say if card 1 is not 0, then we print card 1. Otherwise, we just leave it blank. And then we say if. So it's not else if, it's just if. That way we don't have to do 800 else ifs. We just print only the ones that are valid. So that's the case where we want to do ifs. And list assignment. Honestly, this is cleaner. How is it less clean? Joe is Joe.id. Or we could say ID is Joe ID. I guess it's cleaner. But we need an initializer for Joe's ID. Otherwise, if we don't specify it and we give it a list, then we're assigning it whatever the default value is, which might be 0. Yeah, I gotta pop my knee. There it is. Yep. A struct with another struct of the same type, so we can initialize this one to be this, or I could do specific little pieces and say this one's whatever is this one's whatever, or I could say this one stays the same, and then these two get specified. I could do a bunch of different stuff here, and then we could print them. So you could create a foo called foo, and then create a foo called x, and then the fuck is happening here? Why are we doing direct initialization? Okay, so we could say foo x is foo, we could say foo y is foo via direct, and then we could say foo z is foo like this. And they're all the same. So we can assign a struct, or a struct object of one struct type to another of the same type. Its values, or we could, like, let's see, struct, let's say gun collection. Int gun 1 is whatever, nothing, and then int gun 2. We'll just do 3. Int gun 3. And then we say gun collection uncle guns. Okay. And he has a 3, a 1, and a 2. And then we have gun collection my guns. And I don't have shit. I got nothing. And then fucking hello? Bro, what is going on right here? It's a little... Okay. Uncle gives guns 1 and 3. And then we could say my guns is now dot gun 1, and I can say, and dot gun 1 is aware that it's my guns. I don't have to say is my guns dot gun 1 is this. I mean, I could. Oh, so it doesn't like that. Parent does not evaluate to a function. Taking 1 arguments. Okay, I'm not sure how that works. But we could say dot gun 1 is now, and I guess we do this anyways, because if I did this, it doesn't automatically put the ending brace, so this is honestly more convenient. So gun 1 is now uncle guns dot gun 1. Dot gun 2 is dot gun 2, or is my guns dot gun 2. And dot gun 3 is now uncle guns dot gun 3, because it gave me those 3. And then we could standard OStream reference, operator insertion, standard OStream reference output device, gun collection, gun collection. And then we could say same character output, gun 1, gun collection dot gun 1, gun 2, gun collection, gun collection dot gun 2, gun 3, gun collection dot gun 3. Number 2. Oh my fucking god, I did it again. And then I could update Uncle Guns too. That gun 1 is now, I mean, nothing, I guess. Equals 0. That gun 2. Oh. That gun 2 is still Uncle Guns. That gun 2. Oops. Uncle Guns, that gun 2. And that gun 3 is Uncle Guns, that gun 3. Or, well, hold on. Is 0. What are you fucking complaining about? Oh, oops. Can't reassign it or reinitialize it. Okay. And so, Uncle's Guns at first. Wait, why did it not print it? Hello? Why didn't it do it? Oh, oops. I didn't. Okay, there we go. So, Uncle has 3, 1, and 2. I have nothing. He gives his first and third gun. Now he only has his second gun. And now I have his first and third gun. Okay. Alright. Cool.